Welcome to Bright Spark YouTube channel. Today we are discussing about the parallel circuits. R to R. One resistor is R1 taken. Now there is R2. Both are connected to the AC voltage source. Total current is I of t. Here is I1 flow of current. Here flow of current is I2. This is voltage. This is parallel. Resistance or resistance. Two resistors are connected in parallel. In this circuit, I of t is called in parallel circuits. Total current is divided into number of parallel paths. So here is number of parallel paths, two paths is there. I of t is equal to I1 plus I2. Voltage in parallel circuit, voltage across the each parallel path is equal to the supply voltage. Here voltage is V of R1, here V of R2. V is equal to V of R1 is equal to V of R2. That is equal to V is equal to V is equal to V. This is the okay. Next, total resistance R of t is equal to 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3, so on. Here we take two resistors are connected in parallel. That's why we will take 1 by RQ is equal to 1 by R1 plus 1 by R2. 1 by RQ is equal to take LCM R1 R2 R1 plus R2. R equivalent is equal to this is reciprocal. Sorry, this is here the term is inversely written R1 R2 by R1 plus R2. This is R equivalent. In this purely resistance circuit, that's why Z is equal to R equivalent. Okay. Here find out I total I V Z. In this circuit is purely resistance circuit. That's why power factor of the circuit is unity power factor. Okay, the current in the voltage and current relationship is the voltage and currents are both are in phase, because both resistors are connected in resistance. Two resistors connected in parallel. This is purely resistance circuit. Total R is equal to this one. Okay, I is equal to V by Z. That is equal to V by RQ. This is the total resistance formula. Okay, this is the resistance to resistance connected in parallel circuits. Okay, next we are discussing about RL circuit. Here power P is called V squared by RZ. That is called P is called P square by R equivalent. This is power formula. Okay. Next we are discussing about resistance and inductor circuits. Connected in parallel circuit. Here one resistor is taken, RL circuit. R parallel to L. One resistor is taken, L Inductor is taken to the parallel circuit, parallel to resistance RL. Here is both are connected to the AC voltage source. Here flow of current is IR. Here flow of current is I suffix L. Here is total current is I of T. This is voltage. Okay. Here voltage drop. Here voltage drop is V suffix R. Here voltage drop is V suffix V of L. The voltage across the inductor. This is V suffix L means. Okay. Next. Here flow of I of T is called I of R plus I of L. This is the total current. Here V is equal to same that to the resistance parallel current circuits. Here V is equal to V suffix of R is equal to V suffix of L. That is equal to V is equal to V is equal to V. That means all voltage is same in parallel circuit. Each parallel circuit same voltage to this up and equal to the supply voltage. Next, Z is equal to here 1 by Z is equal to square root of 1 by R square plus 1 by XL whole square. Generally, all of you know Z is equal to R square plus XL whole square. This is for series circuit. This is for parallel circuit. Here 1 by Z is called square root of, here you are taking LCM R square XL square. Here is R square plus XL whole square. Then 1 by Z is called square root of R square plus XL whole square divided into two times. R square plus R square XL square. Square is cancelled. Then 1 by Z is called square root of R square plus XL whole square by R of XL. The Z is called R of XL by R square plus XL whole square. This is the Z formula. Z is called R of XL by R square plus XL square under square root. This is the formula. This is total impedance formula. Okay. I is called in this circuit, I is called V by Z. That is called I is called V by Z means R into XL by square root of R square plus XL whole square. This is the total current find out by using this equation. Here the voltage current relation is voltage and currents are both are in phase. This is resistor circuit. Here is inductor circuits. In inductor circuits, here voltage is reference taken. Here is flow of current I of L. The difference is 90 degrees lag. This means direction is here taken. That is 90 degrees lag behind the voltage. Here we turn. Okay. 9 degrees voltage కన్నా 9 degrees వెనకాల ఫ్లో కరెంట్ ఫ్లో ఇన్ ఇండక్టర్ లో ఫ్లో కరెంట్ 9 degrees లాగింగ్ లో ఉందని అర్థం. Okay, that's why the circuit behaves like lagging power factor. Okay, this is the RL circuit. Next, RC circuit. Here one resistance is taken in connected to parallel, capacitor is taken, both are connected to the voltage source, AC voltage source. Here is V, supply voltage V, flow of current I of R, flow of current I of C. This is I of T. Okay, this suffix of R, here is suffix of C. Same as for the previous circuit. Here is in parallel path, total voltage across each parallel branch is equal to the supply voltage. V suffix of R is equal to V suffix of C is equal to V supply equal to supply voltage. That is equal to same of the supply voltage. This is the voltage. Here total current is equal to IR plus IC. In vector sum, I of t is equal to square root of IR square plus IC square. This is the total current formula. The vector sum. Here total resistance 1 by Z impedance, total impedance is equal 1 by R square plus 1 by XC square and square root of. Okay, this Z. All of you know in series circuit Z is called R square plus XC whole square plus square root. This is the for series circuit. For series. Here 1 by Z is equal to, you take in LCM, R square XC square is equal to R square plus XC whole square. Reciprocal Z is equal to R square XC square by R square plus XC square. This is the, here square root is cancelled. So Z is equal to R into XC by square root of R square plus XC square. This is the total Z. Okay, this is Z formula. Total current you will find out means I is equal to V by Z. Or I is equal to V into Y. Here Y is admittance. Okay. Here in resistance, current voltage relation is in phase with the current and voltage. Here voltage is reference taken. Here's IC, it is 90 degrees. Direction is this like. The capacitor current is 90 degrees ahead of the voltage. That's why the circuit behaves like leading power factor. Leading power factor. Okay. This is the parallel RC circuit. Next, we are discussing about the impedance triangle or admittance triangle. Impedance triangle. Here is admittance triangle. This is R, this is the X, this is the Z. All of you know R means resistance, X is called reactance, Z is called impedance. Theta. Here this is used for series circuit. Impedance triangle used for series circuits. Here Z is equal to Z square is equal to R square plus X square. Here Z is equal to square root of R square plus X square. This is for series circuit. Here cos phi is equal to R by Z. Sin pi is equal to X by Z. In the same way, admittance is equal to reciprocal of impedance. Y is equal to 1 by Z. This is the formula. Okay. Next, resistance is reciprocal is conductance. Conductance is equal to 1 by resistance. It is represented in G. G is equal to 1 by R. Next is susceptance. Susceptance is equal to 1 by reactance. This is S is equal to 1 by X. This is the formula. Here admittance triangle will take, this is the G conductance, here is susceptance, here is admittance Y, this is the pi. Okay, here cos pi is equal to G by Y, sin pi is equal to S by Y. Okay, here G is equal to cos pi into Y, that is called cos phi is equal to R by Z, Y is equal to 1 by Z. Here G is equal to R by Z square. Okay, in the same way, S is equal to Y into sin phi, that is Y is equal to 1 by Z. Sin phi is equal to X by Z, that is equal to X by Z square. S is equal to. This is the formula. This is the impedance triangle used for series circuits. The admittance triangle used for parallel circuits. Okay. Comparison between series circuits and parallel circuits. Comparison between series and parallel circuits. Okay. Series circuits. Parallel circuits. Here, in series circuit, R of T, total resistance is called sum of all resistors. Resistors are R of T greater than R of R large value. అంటే ఇచ్చిన సర్క్యూట్ లో టోటల్ రెసిస్టెన్స్ వాల్యూ ఏదైతే లార్జ్గా ఉంటుందో దానికన్నా టోటల్ రెసిస్టెన్స్ అనేది ఎక్కువ ఉంటుంది అనేది ఇక్కడ మీనింగ్. ఓకే, ఇన్ ప్యారలల్ సర్క్యూట్స్ లో ఆర్ ఆఫ్ టీ ఈజ్ లెస్ దాన్ ఆర్ ఈక్వల్ టు ది ఆర్ స్మాల్. అంటే ఇచ్చిన సర్క్యూట్ లో ఇచ్చిన సర్క్యూట్ లో రెసిస్టెన్స్ వాల్యూ ఎక్కడ ఏదైతే రెసిస్టెన్స్ వాల్యూ తక్కువ ఉంటుందో దానికన్నా టోటల్ రెసిస్టెన్స్ తక్కువ వస్తుందని మీనింగ్. ఓకే, నెక్స్ట్ current. Here this current is same in series circuits. This is current divides. Current divides. Here is voltage. Voltage is V of t is called voltage across each elements, just like that. Here V of t is called supply voltage is equal to the voltage across each parallel branch. That is called V of R. V1 is equal to V2 is equal to so on. This is the okay. Here in series elements connection end to end. It means this is the one end of one resistor. This is the another resistor means if this end is the connected with this end. It's like that. Okay. In this, each elements are connected to the parallel. This like that. Next, power factor. Here, power factor is depends upon circuits. Depends upon circuit. RL for lagging, RC for leading. Here, same RL is called lagging, RC is called leading power factor. This is the comparison between series and parallel circuits. ఈ ఇన్ఫర్మేషన్ వస్తే నా ఛానల్ లైక్ చేయండి, వీడియో లైక్ చేయండి, అలాగే ఎవరికైనా మీ ఫ్రెండ్స్ కావాల్సి ఉంటే షేర్ చేయండి. నా ఛానల్ను ఇలాంటి ఇన్ఫర్మేషన్ కోసం సబ్స్క్రైబ్ చేసుకోండి. థ్యాంక్ యూ వన్ ఆల్.